Good morning, everyone. Um, First, let's do a quick mic check. If you can hear me, can you drop a reaction, an emoji, anything? Just, just want to make sure that everyone can hear me. Does that mean you can't hear me? Hold on, let me check. Okay, okay. I've seen one or two. Can someone else just confirm? Just want to make sure that everyone can hear me. Benedict, can you hear me? Can you maybe thumbs up or something? Okay. Oh, well, at least I think I've gotten a reaction from someone. Anyways, good morning, everyone. Welcome to AWS Academy, FUTMINNA. Today's class, this is our Cloud Foundations class, right? And today we'll be going into Module 5, right? But just to give every other person like a chance, we'll just give some time so that others can join, right? So that they don't miss out on the very beginning of this. But while that's happening, for those of us who are here, right, in the chat, you can drop um, stuff that you've learned during the week, or if you're able to complete the lab, because there was a lab for last week. I didn't even find out if people were able to get that done. So please, if you're able to do that, drop a message in the chat and also talk about what you've learned and what you're looking forward to learn. This is module 5, so we are already halfway through the course, right? And just as stated at the beginning of this class, sorry, at the beginning of this course, right? The last day to complete this course is August 31st, 2026. So by then, after then, this class will be closed and then we'll move on to other classes. But please make sure that you've completed all the modules and labs and assessments before August 31st. Right. Our instructor for today is already here. I'm already seeing him on the call. So we'll just give a few more minutes, right, for others to join so that everyone can benefit from what is going to be taught today. Right. Thank you and welcome. All right. Just again to confirm, can you all hear me? Am I audible? Okay, great. Thank you very much. All right. So today, we have Mr. Toye Yusuf. Okay. Ephraim, can you hear me? I see that you dropped in the chat that you can't hear anything. All right, great. Okay, so today we have Mr. Tuye Yusuf, right? He would be taking the class today. So I'm going to hand over to him. I think he took a class about 2 weeks ago, and it was really amazing. I enjoyed the class, and a lot of people also enjoyed it. So we've brought him back again this week, and he'll be taking us module 5. Mr. Toye, over to you. Thank you.
Good morning, everyone. Good morning, Engineer Victor. Thank you. Let me know if you can hear me so that I can proceed. Okay. I'm seeing thumbs up, so I will assume we can all hear me. Let me share my screen. Right. Can you see my screen? I just see my screen. I'm sharing my screen right now.
Yes, I can see your screen.
Okay, good. How are we doing? How's the weekend going? So today we'll be looking at mode 5, and it has a very interesting topics, networking and content delivery. So quick one before we start the class. The truth is, for this every session we are doing every Saturday, we use 2 hours, right? So we cannot cover everything in detail. So which means at some point in time you have to do your part, all right, so that you can fully understand and you can follow up, and so everything can flow, all right. So because I was just checking this material this morning, I saw it's about 75 pages, and it has a lot of topics that are very detailed, that if you want to go into it, even each of those subtopics in it, all right, it take us probably a day. Do you get? So I will just probably maybe brief over them, and you can go and do the rest, or you can ask questions based on what I've explained, or the areas you did not get, so we can move deep into it. All right. So networking and content delivery. So I believe last week one of our good educators took us the module 3 and 4, right? So which has to do with the AWS security, and the global infrastructure. So I believe we must have by now we know what is a region, availability zone, what is an edge location. All right. So because at some point maybe I'll be referencing them. All right. So it would be good if we, if we catch that, you get. So just as a quick check on us, can somebody just quickly give me a good definition of what an availability zone is? Just a quick revision to check in on you guys. A quick, somebody should help us. Mr. Obini Emeke, please go
Okay,
on.
good morning, Mr. Toy.
Good
An
morning.
availability zone, it's a collection of data centers in a specific region or so.
Yeah, very good. Thank you very much, Mr. Emeke. That's a good definition. You see, and I usually ask this question anytime I see somebody learning cloud, because while I started this journey of about something, I usually have something different in mind anytime I hear of availability zones. You know, I think of something abstract, and not until very, very late I discovered that, oh, it's just data centers, you know, one or more of data centers, or you get. So I think maybe probably the way I studied then. So it's just data centers. We know what's in data centers. Our servers, our storage, everything, the cooling system, you all have it there. Somebody said they can't hear me. But can others hear me? Probably maybe the person's network. I don't know if others can hear me. Okay, I'm saying
I
thumbs up.
can hear you.
The
I
person
can
that
hear
said
you
he
loud
can't
and
hear
clear.
me, probably maybe it's your network. Please, maybe you should toggle off the airplane and. What about edge location? Anybody can help us with the definition of edge location? What an edge location is? Anybody want to try?
Edge
Okay.
location, maybe a data center that's really the one that is close to you. I don't know
Okay.
if I'm right.
Yeah, something like that actually. You know what all these cloud service provider does is that they put some of their devices. They partner with all these ISPs, internet service providers that you know, right? So they place some of their devices in their data centers, all right, in their data centers. So there is not their own, it's not their own, sometimes not necessarily their own data centers. So most of the times that's why it's always closer to you. They look at where users are much, all right, and they look at, okay, maybe a colocation center or an ISP or a data center that is closer there. They partner with them and they put some of their devices there. So that way it's closer to you, right? So, and all the technology that runs there majorly is all this CDN, content delivery network. We get there also, right? That's why I'm asking now. So they put some of their devices there. So that's why they call it edge location, because it's closer to you, right? But you should know that this is some of their devices that are placed somewhere. All right. We also have local zone. We should differentiate that. Local zone is different from edge location. It's different from edge location. It's their own data center, but not in the region. Not in the region where they have the AZ. Do you get that? So now today we'll be looking at some of these topics: networking basics, Amazon VPC networking, VPC security, Amazon Route S53, and Amazon CloudFront. All right. So let's start with networking basics. Networking is like the basics for every technology. If you look at it deeply, all right, you find out that all this fancy technology, people are shouting AI, AI. Do you know that if it's not if we want to, if the whole thing wants to be disrupted, all we need to do is just maybe cut one cable, and everything will go down. People won't be able to use uh, the AI again. All right. That's why as a network engineer, people should okay, maybe I'm saying this from the side of my area of expertise. All right. Networking is like the basics of everything. It connects computers together, it connects services together, you know. So let's unravel it. So they're just trying to illustrate what network is. Right? You can see what we have here looks like a 3PC, right? So we have another 3PC on this side. In between them is a device or router. It's a network device. All right. What it does is it takes message from sender A All right, Mr. Victor, I saw your message. I saw your message. All right, so we saw, you can see we have 3 PCs on this side and 3 other computers on this side. All right, and we can see in between them, we have a router that is the function of that router is a network device. So we have some network device that maybe you should be familiar with. Maybe not necessarily too much, because if you are working with cloud most of the time, your own is just to maybe mention the things you want, create the things you want. People at the back end, because all these things are virtual. All right, so they do the major work for you. All right, yours is to maybe select this what I want. All right, so you can see a router is one of the network device. We have what we call switch. We have what we call firewall. I know most of you will know firewall, because one way or the other you must have heard of it, and maybe some of us will even have something that looks like it, that is software part on our PC. All right, so there's firewall, there's router, there's switch, a lot like that. But one of the major ones you're dealing with maybe in this cloud aspect is router. All right, because for intercommunication, you need something to, it's very easy these days. You just type in, you go to your browser, you type in Google, and everything appears in your front of your screen, right? Isn't it beautiful? It's beautiful, but behind the scene, a lot of things are going on, isn't it? Sometimes that Google you are trying to access might go as far as Lagos, as far as South Africa, as far as Europe, where it is being hosted. All right. All these things are, we don't really need to go deep into that actually, because that's not what our major goal is. So a computer network is 2 or more client machines that are connected together to share resources. So a network can be logically partitioned into subnets. So if you want to divide our network, we can divide it into something called subnets. All right. Subnet 1, subnet 2. They are trying to, segregate. Now there's something called IP addresses. To some extent, you need to know what an IP address is, and probably maybe how to allocate them. Although in most organizations, if I don't know, because sometimes the role you are playing differs. I know most organizations usually have the network person, because when it comes to allocating IP address, they have to plan everything. But for small organizations, you might need to, and it's good, even as a cloud engineer, you need to know very well. I've seen many people, all right, I've seen many cloud engineer or developer saying maybe they went for an interview, and one of the things that disqualified them was that they did not know the difference between a private IP address and a public IP address. All right. So irrespective of your field, this thing is, we are using it every day. Even if you check your phone right now, we are connected, right? You guys can see me, I can see you. All right. What makes it possible is these guys here, this number that I see here. All right, we have something called IP address. It's like an identifier that signifies each of us. If I see 192.0.2.0, this is Mr. A's address. It's like an address that identify each person. Do we get it? So, but we can see here we have now. Let me explain how this IP address work. What we are seeing here is an IPv4 address. All right, IPv4 address. Please, as I'm going on, as I'm proceeding, if I get to a point where you don't understand, you can just call me back. All right. We have IPv4 IP address and we have IPv6. All right. So let me start with this IPv4. This is IPv4 IP address. Something you are seeing here: 192.0.2.0. You can see these dots, right? So if you check your phone now, you probably see something like this. If you are connected to maybe a public Wi-Fi, or you are even your own internet, if you are using your ISP, this is your normal MTN and Airtel, there's a way you can check. You can check for the IP address you are using. You will see something like this. All right. something like this. So now this 192.0.0.2.0, we all know that our computers, the language they understand is what? Is zeros and one, isn't it? So this 192.0.2.0 end up being translated to this, right? It's being translated to this binary numbers, all right? Binary numbers. Now, how do we come about 192.0.2.0? Let me follow their guide here. Okay, there's nothing much. So you see, this first number here, just to make things easy for us. Are we together? To make things easy for us, they brought about this using the numbers we are used to. All right. So we have from 0. We have this first option here. You can see before the point we have 192, right? This 192, it could be any number from 0 to 255. The maximum you can have is 255. Why? If you come to this next one, the maximum you can have is 0 to 255. Are we together? Then this option, 0 to 255. But in this case here, we have 2. This last one, 0 to 255. I don't know if it's clear like that. So, and if any number you have here, all right, is easily translated to the 8 to this 8 bits here. If you count this number here, it's 8 bits. I mentioned that the maximum number you can have here is 255, right? And if you translate 255 to binary, you have 111. Everything will be 1. All right. We are not doing that now. So, but if you count this number 1, 2, 3, 4, 5, 6, 7, 8. What you have here now is 8. So we call it 8 bits. All right. 8 bits. Another 8 bit here. Another 8 bit here. Another 8 bit here. So making how many? If you add them together, 8 times 4, that will give us what? That will give us 32, right? That's 32 bits. That's why you hear they say IPv4 address is a 32-bit IP address. So this is what they mean by the bits. All right. Our machine understands zeros and one, isn't it? That's why we translate this our decimal. We call this decimal notation. We use decimal because it's easier for human being to read decimal, isn't it? But this is what it's been translated to. All right, this 8-bit number. All right, so 8 bits, one portion, another 8 bits, another portion. That's 16, right? Another 8, another 8. That's everything making 32 bits. All right, so IPv4 address. So in case you can be asked, the 32-bit IP addressing. Unlike IPv6, which is 128. So we get there. So I believe we get that now. So I've mentioned 2 things that are very important here. And these guys are 8 bits. It cannot be more than 8 bits. So, and this our decimal, you should know that each portion of it, that each section, we have 4 sections now, right? This first one, we can have from 0 to 255. Here also we can have from 0 to 255. Here we can have from 0 to 255. Here also we can have from 0. I won't delay much because these are not really, we won't be doing much of this if they are not in networking fields. You won't be doing much of this. So let's not dwell too much on this. But I think you have get the main thing I believe you should have gotten the point now. I want you to get from here that the maximum you can have here is from this first is 0 to 255. This second, after the dots, you also have the option of 0 to 255. Here also we also have 0 to 255. Here also 0 to 255. So I can have 0.0.0.0.1, all right? Or I can have 0.0.0.2. I can change it. It can be anything, but the maximum I can have is 255 on each of these 4 sections. Are we together? So if that is clear, If that is clear, okay. If that is clear, all right. You know, I mentioned no, Mr. Yunus, I just mentioned now that it cannot go. I said the maximum you can have is 255. Let me do this. Okay, come here. Let me share my entire screen. 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 Because I want to show you something. Confirm if you can see my screen. Okay, good. Now, I just make mention of something now. I want to do from here, the maximum you can have is 0 to 255. All right. Here also 0 to what? 255. When you come here also 0 to 255. All right. When you come here also 0 to 255. All right. This is an IP address. This is what an IPv4 IP address looks like. There should be dots here. Should be dots here. So I want everyone to give me one IPv4 IP address. Quick one. Everybody should drop in the chat box. From what I've explained now, drop any IP address for me, any IPv4 address for me. From what I've mentioned now, you know, I said we have 4 octets now. Okay, I think we call it octets. Right. So section 1, section 2, section 3, section 4 of first octet, second octet, third octet, 4 octets, right? So everybody, yeah, somebody has dropped 193, very good, very good. 192, yes, very good, very good. I'm seeing beautiful IP address. Somebody dropped 255, 255, 255, 255. Very good. That man likes to use his everything. All right, that's good. That's good. That's good. That's good. So, Joy Akonde, thank you. I can see 192. Why do everybody like 192? Go out of the box. 0.0. Thank you. 0.0. You can have 0.0.0.0. And that one, everything has a meaning. All right. Yeah. Thank you, Engineer Victor. Yeah. 6172.16. Yeah. Very good. That's IPv4 for you. Thank you, everyone. Thank you for participating. I love that. I love that. I love that. So that's the structure of IPv4. So whenever you see something like that, you are not scared that hope they are not hacking my. So don't be scared. All right. It's an IPv4 address. That is the way it's structured. It's 32-bit address. All right. So we have IPv6. You see here. What do you see? Look at this. Oh my God. What's this? This IPv6. You know, something happened. And you know, when I started networking, sometimes I questioned those that created IPv4 a lot. That why? You know, they wasted a lot of IP address. You won't understand this because and I don't even know how to explain it. You know, then it was not their fault. The maximum IP address you could get, you know, I said it's 32-bit, right? And 2 raised to power 32 will give us about what? Can somebody help me to do that calculation? 2 raised to power 32 is the total number of IPv4 address that we have or that we can have. 2 raised to power 36 is what? Anybody with calculator? It's about 1 point something billion, you know. So that IP address was much, you know. Then how many? Then it was just the, you know, this invention of computers, and computers were not much. So people that sat down together and created something called IP address. Someone, thank you, Mr. Abdullah. 4.3 billion, right? Very good. Very good, 4.3 billion. All right, so it looks so much. It's just as if maybe, let me say, like 100 years back. You guys won't know what it looks like, right? Okay. Yeah, let's just let that. Look at those olden days now. Like, you watch all these movies, all right? All these Asian movies, or you see, imagine giving someone how much, let me call an amount that looks big, maybe $1 billion. The person might, might not even know the value because it's like it's too much in their eyes. All right. Or let me just say, I'm even going far. Then they spend coin, or maybe they even trade with cowrie. Imagine they have a money they are spending, and you give them like 100,000. It seems like as if it's much, right? Somebody as far as 50 years back, you give them 100,000. That 100,000, it could do a lot of things. But come to this our current what's it called, economic, what have you, 100,000, even as a student, I believe if you're a good spender, it will not pass maybe a week. Maybe a week is even much for some people. Some people like, let me not mention name. All right. So people that created IPv4 address, yes, Engineer Victor, just like giving someone 1 trillion today. All right. So when they created IPv4 address, then 4.3 billion IP address, it seems as if it's much. All right. So they wasted some of it, and they didn't know. Look at the way the internet, the whole exploration of internet, and everything is interconnected, IoT. Now everything wants an IP address. Guess what? 4.3 billion IP address exhausted, finished. Are you surprised? It's finished. Every single thing now. Everybody has PC. How many people are connecting a day? Can you imagine that? We have the IoT systems, even vehicles nowadays, everything is connecting. So we need more IP address. That 4.3 billion can no longer be sufficient. But then it looks as if it's much. Because sometimes I question them because there are some IP address, the way they waste some IP address, but it's not their fault, we have about 8 billion people on the earth. All right. And most people have probably most people have at least one device. All right. You will hardly find it that maybe a place now where someone does not have a gadget. All right, all these gadgets you need to connect, right? You need an IP address. And some even have 2. Nowadays, it's even worse. You can see people with, some people can have 4 gadgets, can have 2 phones, 2 laptops. You want to connect all of them to the internet, you need IP address. Something that will identify as, okay, this is me. You get it? So the IP got exhausted. Say someone has 5 gadgets. Maybe you dash me one. Oh. Who is that person that has 5 gadgets? Emekeba? Okay, I'll collect one. All right. Are we together? So it's the IP address got exhausted, that 4.3 billion thereabouts. So they need to invent what we call IPv6. You can see the way now they come with full force. You can see how many bits this one has. Somebody should do the calculation. 2 raised to power 128. I don't know the numbers to give you, but you can do it. All right. You can see how long this one is. This one is even difficult. If I say everybody should start giving me one IP address now, you even type, before you even type it finish, you spend like, maybe some seconds. You can see it's very long, right? So this IPv6 is it has 128 bits. All right. So we are not really dwelling much on that, but I think we've understood the structure. So just like I said, now for that IP addressing, how does it work? There's something we call classless inter-domain routing, classless inter-domain routing, CIDR. Now, how do you identify, if you see an IP address, how do you identify that, okay, this is, the IP address you see now, all of you have dropped an IP address. What we do, all right, you can see, I mentioned that we have 4 octets, isn't it? The first octet, that's 8-bit, right? The second octet, that's 16, right? The third octet, 16 plus 8, that's 24, right? Then the last octet, that's the fourth octet. Add another 8, that's 32, right? So now there's something that the way it's been structured for CIDR, we have the network identifier and the host identifier. When you see an IP address, all right, if you want to know, there's a way, especially, although I won't dwell much on this because it might be a little bit confusing. But just note that there is something at the back that we use. Especially this one is majorly at the part of the person that is maybe configuring the network, that is provisioning the IP address. All right. So there's something that I used to specify. This is the host. This is the network identifier. There's something that identifies the network. There's something that identifies the host. Now, what do I mean by that? Say, for instance, this IP address, we have 192.1.0.2.0. Yes. All right. And at the end, they put something. They put /24. Now, this /24, anything that comes after this slash is what will make us to know the network identifier and the host identifier. That is the host, those that are using this particular network. All right, because as we have all dropped IP address, there is private IP address, there's public. We still get there also, and now there's something we call network. All right, something we call network also. Now, how do we identify this network? Just as I've said now, this one now is not, if you are receiving an IP address, you might not really be bothered or not really know what is host identifier, what is network identifier, as far as you can, browse, But at the end of the person doing the job, you have to know, okay, how many IP address are we allocating to people? That will be the host identifier. Then there will be a particular one that will identify the network where all those hosts, where they are. Now look at this, for example, 192.1.0.2, then .0, then /24. This slash that follow is what signify the host for us, that okay, /24. This is one of the easiest way. All right. If we go deep into networking, sometimes you might be using all these. Okay, Sir Victor.
I wanted to give an illustration to help understand the network ID and host ID. Right. So right now I'm in Abuja and I want to send something to Toye. Right. Say Toye is in Lagos. Right. Now I first need to know that Toye is in Lagos, Nigeria. Right, that's like the host ID. That's like the /24. Then I actually need to know Toye's address within Lagos, right? So maybe he is staying in Victoria Island or he's staying in Yaba. That's just an illustration to help you understand the difference between the host ID and then the host ID and the network ID. So now I want to send something to you in Lagos, right? The network ID, that would be like Lagos, right? That's identifying, okay, this is where it is. Then I need to now know where Toye actually is, right? So his house address, right? That would be the host ID. Thank you.
Yeah, thank you very much. I think that's a very good illustration. I think I need to work on that. I think it helps to understand better for difficult technologies like this. Things that are a little bit, if you are new to things like this, you need something to illustrate to explain. I think, and that's a very good illustration. I think we all get that now, right? So yeah, thank you, Mr. Victor. So this slash 24, let us know how many bits are fixed. How many bits are fixed? So if you add 8 plus 8, that's 16, right? Then plus another 8, that's 24. That means this part is fixed, this part is fixed, this part is fixed, right? So only which one is changeable now? Only this guy here, right? Only this guy here, isn't it? So we have what option now? We have 0 to 255. So that means what we can allocate now to people is 0 to 255. So just like Engineer Victor said now, isn't it? That means the address we can have, we've already know that, okay, these are people living in Lagos. Now, the address is from maybe 0 to 255. We have 255 IP address that we can give out. People wants to get IP address. So we can give address to 255 houses. All right. You come, we give you Oshodi. You come, we give you Lekki. All right. You get. So that's how you get IP addresses on your, on your phone. And that's what we identify each person. So one person will have maybe dots. Although there are some that are reserved. For example, dot zero cannot be allocated to anybody. It signifies the network. Are we together? It cannot be allocated. Is what the device itself is a kind of how do I put it? It's a kind of an identifier on its own for that particular network. Nobody can use it. All right. Then we have the 255. The last one, nobody can use that also. The .255. All right. We call it the broadcast. All right. Is one that is used to send message to anybody that is in that address. All right. Maybe anybody that is in, let's say we are using an address of Lagos as an example now. We want to send letter to everybody. We go through 255. You call it the broadcast. All right. So you can see this 0000000. You cannot give it out. And this last one, 111111, that's 255 when you convert it. So it's being converted here. All right. So let's just stick to this slash 24. If what happens now, if I change it to slash 23, it can be a little bit confusing because now if I change it to slash 23, that means from this part here, all these parts here are flexible. I can change them. All these parts here are fixed. All these other parts are fixed. All these other parts are fixed. If I change it to slash 23, it means I'm permanenting 23. Sorry, it's 23, right? What if it's 24? All right. I don't know if you get that. If it's 24, it signifies the network ID. All right, network identifier. You are permanenting this. You are not changing them. It signifies the network. All right. You are not changing them. You're only changing. Now, the remaining one will be for the host. That's what you can, allocate to the host. Do you get that? I don't know if that is clear. So now, somebody should tell me if it is slash 16, how many will I permanent that I can add? What would be my network identifier? Let's say for this 192.0.2.0, if I'm using slash 16, if I'm using slash 16 here, all right, let's say I'm using slash 16 here. I'm using slash 16 here instead of slash 24. I'm using slash 16. That means what I mean here is that I'm fixing 16 bits. All right, starting from here, I'm fixing 16 bits. I will know that from here to here is what? 8 bits, right? So that means 8 bits here, 8 bits here. That's 16, right? So I'm fixing, these guys are fixed. I cannot change them. They will be my network ID. Are we together? Why this other two parts? Are we together? So why this other two? That means I have 0 to 255 here. I have option of 0 to 255 here. 0 to 255 here that I can use. Then we also have 0 to 255 here that I can use. So this will be my host. Are we together? I don't know if that is clear. So anytime anything that comes after the slash is telling you the thing the IP address that needs to be fixed and the option that you have that you can and the remaining part is telling you the option that you have that you can allocate. All right. So that means I have 16 bits left. 16 bits left that I can change, isn't it? So let's not dwell much on that. But if you understand this, let me know. Quick. Thank you, man. All right. Sorry about that. I don't know if you get that. If you just get this, we can always.
Engineer, so if it's something that maybe they need to revisit, right? Maybe we'll find like a video, right, that will send to the group chats that will further explain
Everything. Yeah, because even for networking students, this part usually takes it's not
some
something
time
you
to
can.
understand.
Yeah, it takes time, and I don't want to. And it's something you need to understand, because when you are creating your resources on
VPC.
cloud, especially when we get to VPC part now, you see you need to specify a network. So you need to understand, okay, why am I using /24 here? Why am I using /16 here? So let me just say this while we are here. So when you're having, now you should have taken note of something now. The higher this number goes, all right? That means the smaller the IP address you can allocate to people, right? Or to hosts. Are you together? So, but the smaller it gets, the bigger the number becomes. That's the host identifier. Is that clear? Networking can be a bit, sometimes interesting, and sometimes, you have to calm down to get some of those concepts. Are you together? Okay. Sorry, I'm trying to change my. Please let me to close that. Please let me close that door. Yeah, sorry about that. Sorry about the interruption. So let's proceed. Let's proceed. I know we have hit a particular spot now. It's that's a bit challenging, isn't it? What's this? All this /24 /. Don't worry about it. You just need to take time. Take time. You get it. Just understand some of the little basics around it. Then you are good to go. Then just know one of the key things I want us to hold from here is that this slash, anything that comes after this slash, all right, is the number that will be fixed. So if you see /24, it means you are fixing 24 bits. That's 8 plus 8, 16. Plus another 8 here, you are fixing all these parts, isn't it? All right. This conversion that they did to make it, we're using this decimal to make our work easier, to make it readable. But this is the language computer understands, isn't it? So if we're using /32 now, that means what will happen? How many IP will you have? Now, let's go to OSI model. OSI model. I think OSI model is something you should be familiar with. All right, its structure is a good structure of how everything works. You know, there have to be protocols for everything. Without protocol, you know, there will be chaos. There will be chaos. Prior before OSI model, you know, when they begin to make computers, you know, maybe a particular company, let me say IBM, for example, make their computers. You know how gigantic computers were then, you know, and another company, let me say company B, make their own computer. It's not easy to communicate with each other because, you know, the way the computers are being made are different. So we need to make a particular structure of protocols and how everything will be done. So it doesn't matter which computer you are using, you know, which application you are building, you use the same protocol. All right, you use the same protocol. If you want to send, it's the protocol you use. All right, so we have what we call open system interconnection model. It's one of the foundation of the communication. All right, that forms communication. We have the OSI model, and it has a 7 layer. That's 7 what? 7 layer. We have the physical layer, the data link layer, the network layer, the transport, session, presentation, and application. Are we together? So we have the physical layer. That's the one everybody see. You know, behind every, what's it called? Just like I said, internet is like interconnection of computers. All these things are done through, you know, physical cables. It's not by magic. There are cables somewhere that are interconnecting. You know, even though the world has advanced, now we are not using Wi-Fi. You know, we can connect to all these microwave, all these wireless technologies. You know, it used to be physical before. You have to plug in a LAN cable or Ethernet cable to your PC. All right. So we have the physical, we have the data link, that's the LAN. We have the network, that's the routing and packets forwarding. That's why we have the internet protocol, what we just finished now. So this is where they created, you know, all those protocols, the IP, IPv4, IPv6, you know. We have the TCP and UDP. They provide protocol to support host-to-host communication. We have the session, layer, that's number 5. We have the presentation layer, that's number 6. We have the application layer. All right, so let's take note of that. These are, they mention one protocol, each of those protocol for these layers. For physical, the protocol is what? Or address is signals, that's the ones and zero. Ones and zero. While for data link, we have the MAC address. For network, we have the IP address, you know, internet protocol. We have the internet protocol. For transport layer, we have what we call TCP and UDP, transmission control and user datagram protocol. All right. So just know that these are layers of interconnection. This OSI is a foundation, although it's not longer being used, but it's like the foundation. You know, now we use they've compressed it to 5. This presentation and session are now being made to application. All right. I know presentation, transportation, session, and now is compressed to, that's 4 now. Presentation, session, transport, or session and presentation are now being made into application. All right. So because you know, after some improvement and everything, they realize, okay, maybe we can merge these 2 guys together. You know, there's a lot of things that go under there, but this is the foundation of the model for how communication between system or computers, how data travel, right? So the one that concerns what we are doing is the layer 3. Although everything also concerns it, but maybe majorly what we are dealing with networking, right? We talk about IP, right? So it's this guy. So all our routers work at this layer, right? So we also have what we call switch. They use this layer too. So don't worry much about them. Just know them. Okay, that we have these 7 layers and these are their protocols, right? You can do the assignment. Check each one of them. It's the foundation. It's good if you know them. All right. It's good if you know them. It's the foundation of the intercommunication. I don't know if you guys can hear me.
I can hear you loud and clear.
Okay. Very good. So now let's go to something interesting. VPC. Now we have come to where we really are going. So all this one are just preparation to what will come ahead. If you understand what we have said, it might not take much time, because all what we have said earlier will be something that we'll be using here. All right. Amazon VPC, virtual private cloud. All right. So I think when creating resources on the cloud, one of the things that make some of your resources isolated. There are a lot of people that are using the same cloud service provider as you. All right. One of the things that makes your own resources, to be isolated from theirs when you have create your account is VPC. So VPC gives you a logically isolated section. All right. It gives you a logically isolated section of the AWS cloud. AWS cloud has a lot of resources. You can provision anywhere you like, right? But you need your resources to be private, isn't it? So how do you do that? So it's done through this virtual private cloud. All right. So there are some resources that you cannot provision except you provision them inside VPC. All right.
Sorry, Mr. Tui, I don't know.
Yeah.
I'm not seeing your screen. I don't know if you can reshare.
Okay. Anybody? Okay. Can you see my screen? Can some people see my screen?
I think it's a general thing.
It's a general thing. Okay. Please always speak up, please. Okay. How about now?
Yes, I can see you on Amazon VPC. Thank you.
Okay. Sorry about that. I didn't know. Where's my phone? Okay. Sometimes I use my phone to check if I'm out. I didn't even check this time around. Okay. Very good. So I mentioned something. I was mentioning Amazon VPC, right? So it enables us to what? To provision, to isolate our resources. All right. So there are some resources that cannot be provisioned without you creating a VPC, isn't it? You have to create a virtual private cloud. So Amazon creates a virtual space for you. Your resources are enclosed. No other person can get access to it. We get that. So it's easier for you to provision your resources inside that VPC, right? Think of it as maybe a government allocated land. The government gives land, or maybe a land that might not even be government. You want to get a land. What happens when you get a land? You have what's it called? I don't know much about land, but I know there's something that you do that specify your, what's it called, your boundary. Okay, this is where my land, which is maybe I'm buying 50 by 50. All right. So this signifies where my land starts from and it ends. I'm just using that as an illustration. Is just a way to, they build that kind of structure for you. So that's why people trust, cloud service providers. Yeah, there's no way our services are safe. They are logically isolated, because one of the concern is security. And how do I provision something on other customers that are using the same cloud service? There are a lot of security that are put in place inside it. All right, but one of them is also VPC. It isolates your work, and it even make it easier, for you to connect some things together, right? So it gives you control over your virtual networking resources. You can select your IP address range. You can select subnet. Some of your services will need IP. So how do you do that? So with VPC now, when you are creating your VPC, you will select the IP address range. You will select the subnet, right? So it enables you to customize your network, and it also enables what? Multiple layers of security, just like I've mentioned. So everybody creates VPCs, right? So aside from just having an account, so that VPC is what, because all of you have an account on AWS, you and other customers, isn't it? But when you create your VPC, your environment is isolated. This person has bought this land. I fence it for him, right? That's his boundary, that's his region, just saying. So it's dedicated to your AWS account. It belongs to a single AWS region and can span multiple AZ. Now, this is one good thing about VPC. When you're buying VPC, it's not tied to a data center. Say, okay, for example, I create a VPC now. Maybe I create it in US East 1. Then I have to choose that availability zone. No, it span across the whole availability zones. You understand? But it belongs to a single region. I don't know if you are getting it. It belongs to a single region. If you want to create another resource in another region, then we need another VPC, isn't it? Yeah. If you need VPC in US, you need in Africa, you have to create in those two regions, right? The only cloud provider that I know, maybe their VPC, I think it's only Google that is a bit different. I think other cloud providers also like that. In Google, have their own VPC region is not tied to region. But that aside, it's region specific, but it's not tied to an availability zone. It encompasses it spans those multiple availability zones all together. Now, but subnet, now we need to take notes. It belongs to a subnet. Now, I said when you're creating VPC, you create your IP address, you create your subnet. Now, subnet belongs to a single availability zone. I don't know if you might have been working with, maybe for some of us that might have been working with other service provider, might find this very strange. I think this is how AWS operates. Is one subnet to one availability zone. You cannot have one subnet span across an availability zone. All right. And I think I like that a lot, because it makes your work easy when you are creating IP address, But you should note that a subnet belongs to a single availability zone. This subnet, if you create it in US East 1A, you cannot use that subnet in US East 1B. I don't know if you are getting that. Right? Subnet can be classified as public or private. So we have public or private. I mentioned earlier that IP before that I mentioned, I said we have public IP address or private IP address, right? So For private, from that word, private means is a localized IP, the IP that cannot, that can be used within a particular space. It cannot go over the internet. Right? When I'm talking a public subnet, that's a subnet that you can use to access the internet. You get that? And even for us that as we are talking now, everyone, for you to be able to go over the internet, you need a public IP. You can't go over the internet with private IP. And there are several reasons why, right? I'll mention that. You see, a private IP, when they see that, okay, there has been, as the exception of IPs coming, we have some IPs that are private. They can be used anywhere. They can be used anywhere. Let me give you that as a bonus. All right. Anytime you see this IP, just know they are private. Maybe you can can you see my screen? I'm trying to do something and it's not showing.
You can see your own subnets, or can't really see anything.
Okay. I'll comment. I think I'm sharing my entire screen. It's not showing. All right, no problem. Let me use notebook. I'm trying to use this. I want to give. Oh, the notepad is not showing as well. Let me share my screen. Because I'm sharing my entire screen. Okay, I already share Windows. Sorry, thought I shared my entire screen. All right. This is what I'm saying. I said we have public IP address and we have private IP address. All right. Anytime you see these IPs, you know you are dealing with these are private IP. You cannot use them over the internet. 10.0.0.0. We have 172.16. Yes. So this one is to 172. IP addressing is a lot, but we'll take it one step at a time, So when you see these guys, just know you are dealing with private IP that cannot be routed over the internet. Are you together? .0.0. I don't know if that's good enough, right? Can you guys see? Let me bring it up here.
Yes, sir, it's bold enough. I can see it.
Okay. So these are private IP address. These are private IP address. Oh, sorry. I wanted to switch it. All right, so that's private IP. It cannot be routed over the internet. All right, use them in your own local. And if I'm using it here, you can also be using it over there where you are. So everybody uses it. It's not unique over the internet. So for you to be able to access the internet, you need a public IP. And how do you get that? All right, that's where your ISPs come in. Your MTN, Airtel, I don't know, Spectranet, Starlink, whatever you are using, wherever you are. right? They're the one that give you access. They give you that public IP. Now for AWS, they have public IP. So they can give you access to, they can make you get access to some of your, they can make you get access to internet. All right. So if you want to get access to internet, you need to make your subnet public. All right. Say, for example, I want to create an EC2 in my subnet, in this subnet, then I need to make that subnet a public one. All right. We'll see how we do that. After I create a VPC, you can divide it into one or more subnets. You can add many subnets as you reach. All right. You know, subnet is just like dividing your network. Dividing your network. Now, one thing you should note. Okay, my screen just went off. Can you guys see my screen? It went off on my phone.
No, it's not showing.
Okay,
It's
I can
blank.
see that from. Okay, I can see that from my phone also. Let me reshare. Okay, I'm sharing again. How about now?
Yeah, it's coming up. It's okay now. It's showing clearly
Okay,
now.
all right. Okay, very good.
Yes, it's okay.
Okay. So when you create a VPC, you assign an IP address. That IP address you assign, all right? You assign a range of particular IP address. Most of the time, AWS will advise you to assign /16, right? /16, you can see how many IP address you get. You know, when we were doing that IP addressing earlier, when you see this /16, what does it mean? It means you can fix 16 bits, but the remaining 16 bits can be allocated to host or to devices. If I say when I mention host, just know that I'm talking to the devices or you as a person that is using that or your services. I don't know if you get your services. If you are provisioning EC2, they'll be getting from all those IP. Are we together? So now, if you are creating a VPC, they will ask you, what IP address range do you want? So most of the time, because once you create that VPC, you cannot change the address range. You cannot change it. Just like, you know, they give you a land, you build the house, you know, you cannot change the design after you've completed the house. Except you want to, you know, maybe clear everything and start all over. The same thing happens to VPC here. You get? So that's why you have to plan IP address depending on what you want to do. You might not need to worry much about IP addressing if what you are doing is not that much, you know, but for organizations that are dealing with, you know, big, a lot of infrastructure and a lot of services they are provisioning. So they take this IP addressing planning very serious. They plan it ahead because if you didn't plan it ahead, you know, sometimes you might want to connect your cloud, some of your cloud services to your on-premises network. All right. Or you might even want to, you know, you might even want to create so many VPCs. All right. So you need to plan accordingly. Do you get? So if you are putting /16, all right, so you are fixing 16 bits, you have 16 bits left. Now, if you want to, 16 bit, that 16 bits can be allocated to host. If you want to calculate it, that how many IP addresses available, just do 2 raised to power 16 to give you this, right? 65,536. But if you have /24, oh my God, I think my screen went off on my phone again. I think it's network or something. Oh, can you guys still see it from my end?
Yes, I can still see it.
Oh, probably my phone network. Okay, it's back also. Okay, very good. So I'm saying something. What about if I choose, when I'm creating my VPC, I choose /24 here. Something will happen. If I choose /24, how many bits can I change? 8, right? Are we together? How many bits can I change? That's 8, right? how many IP address will that 8 give me? Those are the address that I can allocate to hosts. You know, I mentioned network ID and host ID. Right? That means I can allocate, if this one is /24, that means I only have 8-bit left. Now 3 raised power 8 will give me about 256 IP address. So that means I only get to be able to use 256 IP address. All right. So let's go on. That's for the block, for the VPC address block. Now we now have, there's a way you know, this VPC block address, you now share it among your resources. You know, you want to create different resources now. All of them cannot be in the same, they cannot be in the same, you cannot use the same IP address. You want them to be in different network. All right, just like your EC2 and your database. All right, you want your EC2 to be in a different network. You want your I know that might sound strange. Let me look for something that you can relate with. Take for example, you know, if you want to build a room, all right, you have kitchen, you have rooms, you know, create kitchen for what? For your utensils, all right. You want to create room for your utensils, room where people can sleep, room where you can, you know, have entertainment, all right. So you want to find a way to segregate. So the same thing is happening here. You want to build different services, and sometimes you don't want them to, you know, be in the same localization. You want to separate them, right? So you will separate them from this allocated land. This one now is you are the one that is choosing the size of land you want by yourself. So now don't short yourself by choosing maybe a smaller number. Say for example, you are choosing /24. All right, that's the CIDR block of the VPC, right? The CIDR block of the what? Of the VPC. I think the largest AWS give us is /16. So the largest you can even choose is /16. That's 65,536. Now out of that /16 now, you can now have subnets. All right, but if you have already choose /24, how do you now divide it? You know, it becomes smaller now. So you choose a bigger block. From that bigger block now, you know, it's just like they give you allocation now. Then you go and carry small land. You know, the size of your room will be small, isn't it? When you are building your house, why is my own room now small? But you choose big land because you know you're a man of capacity. Don't worry, give me that 1 hectare. You know, it gives you space to build as you want, isn't it? So there's no wastage in it. You can choose /16 for your CIDR block. That's for the VPC CIDR block. So the largest you can choose is /16, while the smallest you can choose is /28. Are you together? /28. Now somebody should tell me so that I can know if you are following. /28. /28. That means we are fixing 28 bits. How many bits left for us? How many bits left?
I think 6.
6, right? Yes. 28 plus 6, that's 32, right? I'm not good at maths. That should be 4. That should be 4. Now, that means how many IP addresses can we get from that now? Just do. Thank you, Mr. Meke. That's 4. So that should be 2 raised to power 4, right? 2 raised to power 4. How many IP addresses will we get from that? 2 raised to power 4 is what? 2 times 2, 4, 4 times 2, 8. That's 8 IP address. Oh my God. And from that 8 IP address,
I think that's 16. 16.
Oh, that's 16. 2 raised to power 4 is 16. Oh, sorry. I was doing 2 raised to power 8. 2 raised to power 3. Okay, that's 16. And from that 16, AWS has some that they have already allocated to themselves. We cannot use them. They already have 3. That these ones, don't touch them. Now that means you have how many left? And remember, out of that 16, naturally safe. I mentioned one that you cannot use now. The .0 and the one with .255. All right. So AWS allocated some to themselves also. You know, in essence, what I'm saying is that it gets smaller, and if it's not enough for what you want to do, you cannot change it. You have to delete the VPC and create another one. So you can always use /16, isn't it, as the CIDR block. Then when you want to do the subnet, you can pick smaller size depending on what you want. For the subnet, you can use /28, right? The subnets all live inside the VPC, inside the VPC CIDR block. I don't know if you get that. I use the analogy of a house and of a land that is given. Then you want to structure your house there. So VPC CIDR block is like the land that's been allocated to you. All right. So now you can it now depends on you. Maybe you want to be building the house small. Okay, let me build one here. I'll build another one here. All right, that's your subnet. You get that now? That's our subnet. So depending on the services you want to provision. All right. So I was mentioning that we serve IP address. So a VPC with an IPv4 CIDR block of this /16, 10.0.0.0/16 has 65,536 total IP address. So the VPC has 4 equal size subnets. Okay, you can see they are choosing a particular, they are showing us an example here. Look at the CIDR block they use. They use if you are picking a CIDR block for your VPC, it has to be one of those private subnets that I showed you earlier. All right, those private, either 10.0.0.0 or 172.16 up to 31. All right, or 192.168. Those are the private subnets. Are we together? You have to pick from there so you can specify either of them here as your CIDR block. Now, from them, now you now create your subnet. You can see we have subnet 1 here. Subnet 1. You can see they use /24. See, that's managing 10.0.0.0/24, which means this guy here is the one that identifies our network. It tells us the location, just like Mr. Victor said the other time. Your network is like the location, show you like a location. Let me just mention it that way. It like show you a location. Let's say it's like a location. Screen is off again. Is it from my end or everybody's? Is it from that person end or everybody's not seeing it? Because I can see it from my phone.
I
Okay.
can see it.
I can see your
You
screen.
can see it. Some people cannot see it.
It's back. It's back.
Sometimes, okay. Sometimes this network, it fluctuates a lot. And it's a network engineer that is doing this thing. How come? There's some things you cannot, it's not in your hand. You cannot, you cannot avoid them, So what I'm saying in essence is that from this, you can see that from this CIDR block of the VPC, that's where we are picking our subnet from. Here we have /24, 10.0.0.0/24. What's the difference between this subnet 1 and subnet 2? You can see this one has 10.0.2. This one has 10.0.1. This one has 10.0.3. Now, just like, we mentioned that time that if it's /24, you are permanenting these guys, right? So you can only change this guy. But something is changing now. This will now make you go back to what we said earlier when we were saying network identifier. There is something, this subnet and this subnet now, by default, naturally, they cannot communicate. Why? Because they are in different, on a normal ground, they are in different network. All right. Now, they are in different, let me just use location, for example. This one is 10.0.0. All right. This one is 10.0.2. These two is like the identifier. the ID, we mentioned the network ID, isn't it? This 3 here, you can see this one is different. This one is also different. Can we see? You can see that's the network identifier. This one already identified, makes us identify the network that anything in 10.0.0.0. All right. So any resources you create in this subnet, they can talk to themselves because they are in the same area, they are in the same compound. All right. But when we come to this subnet 2, it entered another state. Let me say like that. So you need something to link you. You need a road to link you from this state to this state, isn't it? Don't worry about it. There's a lot with IP addressing, honestly. But just take those logical illustrations that we are doing. All right. So from this now, you can see we have 251 IP address available, isn't it? 251 IP address. If you remember earlier, the total IP address is supposed to be 255, isn't it? 255. The total IP address, 2 raised to power 8. We have 8 bits left. 2 raised to power 8 is 255. So supposed to be 255 IP address. But I told you that there's an address that you cannot use, the network address. That's the first 0 and the 255, which is the broadcast. This one is always reserved for everybody to know that, okay, this is the starting point of our family. I don't know if that will explain it better. Network address is just like telling them, okay, if you are in this, our family start from here. So if you are in this 10.0.0, our family start from 10.0. It's just like an identifier that, okay, our family starts from 10.0.0.0. All right. Like this one now is just to identify their family now that, okay, our family starts from 10.0.2.0. This is us. Anybody that have this 10.0.2, anything that come after this 0 now, they are from this family. I don't know if you get it. So that 2.0, that 0 is always reserved. It's a network address. It's one that, like, okay, identify everybody that, okay, all of us we are this family, or we are from this country, or we are from this location. All right. So we can talk to one another. All right. We can talk to one another. Are we together? So the same thing here, you can see 3.0. So they are reserved, their network address. And the last one, .255, is a network broadcast address. If there's an information that needs to be passed to everybody that is living in this location, or in this country, or in this state, I'm just using that illustration word so that we can get it. They pass it through this guy. So this guy is reserved. That's why they call it broadcast. We all know what a broadcast message is, right? Sent to everybody. So if there's a message that needs to get across to everybody, it's sent through this IP address. Are we together? It's sent through this IP address. That's why I say you have to do some assignment yourself. If not, if I really want to go deep into this, we will get it, I will break it down, but the time will not permit us. So you need to do some assignment. Now, these ones are what I mentioned earlier. These are what I reserve naturally. Now, AWS reserve 3 for themselves that you cannot use also. Now, AWS also reserve 3 for themselves that you cannot use, which is what? They use the first one. That means there's no how. You cannot allocate 10.0.0.1 to any of your resources. They use it for internal communication. There's a lot. Honestly, I would have loved, but there's not much time. There's a way cloud networking works. It's a little bit different from normal networking. All right? It's a little bit different. So 10.0.0.2, they use it for DNS. All right? So let's see for DNS. DNS is like translating your your name to IP. We all know that these days, when you want to check any website, you don't need to know the IP address. All you need to know is the name. Google.com, unicorn.com, but those are not the actual, They just make it a lot easier for us. imagine your contact list now. If you want to memorize everybody's number, it will be difficult for you. But by name, if I want to call Mr. Victor now, I just need to go to my contacts, search for VIC. Before you know, it brings everything out for me. It brings out the number for me. It's the number I'm calling, not the name. The name is just for me to identify it. So the same way this DNS works, just for easy remembrance. So there's a kind of service that's already in place. Anytime you enter that name into your browser, it is translated. That name is translated to the IP. That IP is the number, that you are dialing. Are you together? Is the number. Now, they also reserve 10.0.0.3 for future use. All right? For future use. Are we together? So, 5 address is gone. So imagine you're using /28 that you have 16 address. 5 out of 16. So, there's a lot, actually. A lot. So, we have public IP address. I mentioned public IP address. You can't get access to the internet without public IP address. So AWS provision for 2 types of public IP address. You have the public IP before you have the elastic IP. So the one that you'll be using most of the time is this. Anytime you create the resources, there's one that come with it by default. That's the elastic IP. All right. There's one that you need to manually assign yourself. All right. It does not change. I hope I'm not missing it. I hope I'm not mixing it up. Yes, it's the public IP that is manually assigned through an elastic IP address. So the elastic IP address is allocated when you are buying your, for example, maybe EC2. All right, and you buying your EC2, provisioning your EC2, it comes with an elastic IP address. And one thing happened, if you're not using a public IP, if you're using elastic IP, if you didn't change it, if you didn't add this public IP, when you turn that EC2 off, when you on it again, it gets another IP address. It's just more of like a temporary IP address. All right, it's more of like a temporary IP address. So imagine you're hosting maybe a website on an EC2. You need something that is permanent. So you go for public IP before, right? So elastic network interface. This is common, all right? Although it's virtual here, but think of it as the network interface card on your PC. If you have PC, without a network interface card, you cannot browse. Okay, nowadays it's not common. There are some that you can easily see them and connect to, but every PC, every device has a network interface card. That's what enable you to get IP address. All right. So for AWS on the cloud now is a virtual network interface. All right. You can attach it to an instance. You can attach it, you can detach it, you can attach it, you can remove it. All right. So, but by default, you have every instance in your VPC has a default network interface. Because imagine you create an EC2 and does not have interface. Where are you going to send something to? Yeah, remember that IP address is one that make us know, okay, we are sending something to this person. It's make us identify you, isn't it? So you need a default network interface. So you can add more if you want, right? Depending on what you want to do. You can always, so this is symbol. Just take it over this symbol actually. Maybe it might help you. Elastic network interface. Look at this. And even in real life, I think this is what it looks like. Those of us that are familiar, that are good with hardware, they are good with hardware. If you've seen network interface card before, it looks something like this. Let me bold my, I can't zoom more than this. You can see that, right? So it's what is used to communicate. Yes, what is used to communicate. All right. Now there's something called route tables. This is very interesting. everything is nothing is magic. You know, there's plan in your VPC now, and this is the reason why you have a VPC, and you have to create a VPC. All right. For your resources in your VPC, people want to access them. People want to access the resources, or the resources want to access the internet. I like using EC2 for example, as an example, because it's something we are familiar with. Just think of EC2. It's a virtual server. It's a virtual server. You know, you can picture in maybe something close to it, like your PC, right? Although it's not your PC actually. The server is a little bit different, a lot different from PC. But just picture it as your PC. You want to access, you know, you want to access those resources, like your EC2 want to access the internet. Those things, there's something that guides out how those packets or how those data, how our data travel. There's something that guides it. Wherever you are now, all right, we don't see it, so we don't know. When I enter my web browser now, I enter google.com. If I tell you where, if you want to see, okay, let me just do one. Oh, that's not necessary. All right, I'm going to show you how maybe the way our data travel. It travel, you know, on some of the network devices that we call routers. You know, immediately it leaves our PC, our phone, you know, goes through the ISP, you know, before it gets to the destination. There's a destination. All right. So everything is guided by what we call route table. Now we are on route level now. All right. So a route table, what does it contain? It's a set of rules that directs how your traffic, how your data, you know, how it travels. All right. So each route specifies a destination and a target. By default, every route table contains a local route for communication within the VPC. They made this very easy. Most cloud service provider, because of course, most people are not familiar with networking, so they did a lot of things that are already working by default. So you have nothing to worry about. Even when you create your AWS account, by default, I think they create VPC for you in every region. Every region, they create a VPC for a default VPC. And there's the route. You already have routes. So you can see it's easy for you. Maybe for some of us that have the account, you can easily buy EC2 and start accessing the internet once you have a public IP attached to your EC2. Because AWS have done most of those things by default. All right. But now, what about if you want to create your own VPC? Because that's AWS default. They created a default VPC. You can delete it and create yours. All right. You can delete it and create yours. And now, if you are creating yours, there are some things you need to create. You need to create some routes. All right. Are we together? So, I said by default, every route table contains a local route for communication within VPC. Now, by default, you see when you are creating your VPC, immediately you specify a CIDR block. All right. A VPC CIDR block. That, okay, I'm using this particular CIDR block. It could be 10.0.0.0/16 or 192.168.0.0/16, however I want it. If that's my VIP CIDR block, AWS make it very easy. So they create a route called target local, so which makes it easy for anything you create inside that VPC can communicate with one another, depending on your security group and network AC. I think we get there also. But there's already routes so they can communicate. You get anything you create inside this guy, inside this subnet now. Any subnet you create now, you know, by default, they use this local. There is something called local targets. You can see destination. If you are going to this IP range, the target should be what? Local. So there's a local route they have created on their own devices. All right. So, and each subnet you create must be associated with a route table. You must associate your subnet with a route table. At most one. At most, not at least though. At most one. A subnet cannot be attached to more than one route table, because if you attach more than one route table, you know, there might be difficulty, there might be confusion, you know, because route table is just specifying address. You are sending somebody a message. You are telling that, see, I want you to buy me food. I want you to get it from McDonald's. And when you are going to McDonald's, make sure you pass this road, this straight road. All right. Don't cut corners, all right. So you are giving instructions as to how your traffic will pass, and that's what your route table does. You give instruction. When you are going to so place, follow this place. All right. Follow this place. So now, if you give one instruction here, all right, that's a subnet. You attach it to a particular route table, and you go to another route table, you attach it again. There might be a little bit of confusion, you know. Okay, they mentioned something here. The target is targeted. You cannot customize route table by adding routes. You cannot delete the local route entry that is used for internal. Yeah, okay, I think I forgot to. You see this particular one that I created for you. You cannot delete it. It's default. All right. You can add routes, some routes by yourself, right? Some routes by yourself. All right. You can probably maybe change them or something. But this one cannot be deleted. It's by default. You can't delete a default route. You can override it. If you can override, there are some routes that the AWS created for you. You can override it, but not that one. So each subnet in your VPC must be associated with a route table. Are we together? The main route table is the route table is the route automatically assigned to your VPC. So it controls the routing for all subnets that are not explicitly associated with any other route. Sorry for the interruption. Each subnet in your VPC must be associated with the route table. Yeah, I think we mentioned that. Mentioned that. Please, you can go over them. Okay, go over them. These are key takeaways. VPC belongs to one region, subdivided into subnets. A local route cannot be deleted. All right. Yes. I think we've explained all this, so it will be easier. So we have this. We have a public subnet. We have a private subnet. No, now you know I mentioned public subnet earlier. Although this thing will be easier if I do a lab. Okay, maybe next time we just go straight to lab. I will just use lab to explain. It's easier that way. Now, can you see this route here? Destination 0.0.0.0/0, and the target is what? This target is the person you will send, the person that the traffic will be forwarded to. All right. Anything that is coming, anything that is going to 0.0.0 from this your VPC here, from your VPC address here. If you have anything that is going to 0.0.0.0/0, you should forward it to internet gateway. When you see this 0.0, what does it mean? This 0.0 means if it's going anywhere aside from this guy that is up here, right? Because we mentioned we've mentioned this route already. So if you mention a route, that is not on your route table, all right, this guy will send it to the internet gateway. Are we together? I don't know if you get that. So this is for the public subnet actually. For the public subnet. This route here, this 0.0.0.0/0, it means that's destination, right? You can see there in our route table we are saying if we are going to now this subnet, this route table is for this subnet. You can see it's a public subnet. Not this guy. This guy is private. This guy does not have this route. That's the one we finished earlier. It does not have internet gateway. They are trying to mention how we can, go over the internet. To go over the internet, you need a public, you need a public subnet. And for that public subnet, it means you bind on what? There's an internet gateway. AWS has an internet gateway. That's their hand. You don't need to worry about what it is. But at their hand, they have anything that wants to go through the internet. We pass through that internet gateway. All right. So for you to be able to go over the internet, you must have this route. Then you must have a public IP bind to your sources. Let's say this is an EC2. All right. This is an EC2. It has a public IP. Then you create this route. This route is just simply saying 0.0.0 if you are going to this destination. All right. If you are going to this destination, go to internet gateway ID. And what this means is that because we specify every other route that we want, it's usually have many routes in the route table, but since we don't have any resources here currently. All right. So it's saying after this destination, all right, we already have a destination here. We have the target. If you are going to this IP address, all right, go locally. This is a VPC. This is within the VPC. That means any communication of 10.kinicon, let it be within the VPC. The local network is not going over the internet. But anytime you want to go elsewhere, this 0.0 is anywhere. Is an I call it what do we call it? It signifies that if you are going anywhere aside all the routes that we mentioned earlier, all right. If you don't know a particular route, we call it default route. It's just like giving an instruction that okay, buy me burger. If you don't see burger, buy me meat pie. If you don't see meat pie, buy me this. Then if you don't see anything at all, then go to or buy me this. You understand? It's like a explicit declaration that okay, if you don't know where you are going, all right, if you don't know where you are going, just go to this internet gateway. Although I don't like to use that word professional, but let me just put it that way so that you understand. It's like a default route that says aside all what you have specified, all the destination we have specified here, if you are going to a destination that you don't know, right, if anybody is going to a destination that we do not know, right, we don't have this route, send that traffic to the internet gateway. Now, internet gateway is the gateway that AWS has created. Mostly, it's usually a device, probably maybe a router. All right, the traffic will pass through. So from there, AWS send your traffic to the internet. They are trying to access the internet. Are we together? I hope I've not.
You're on track, sir.
Okay. Because everywhere is silent now. All this technology are a bit, a bit too much. Which one is
I mean,
which one is going everywhere?
it's a lot, especially the networking aspect,
Networking
right?
is a lot.
It's very
Honestly.
interesting, but it's not something you can learn in 2 hours. And that's
Yes, it's
why
not
we
something.
always encourage everyone to have gone through the videos and learning materials first. So at least you have an idea. And then when we come on Saturday, we can just build on that, and any part you don't understand will help you to figure it out. Well, I guess they can still always go back to the platform and still review those stuff.
Yeah. Yes. Please review it, and maybe any time of our session, you can always ask questions. And that's why we are even here. Ask questions. All right. Thank God you have a lot of professionals. You have me, you have engineer Victor, you have engineer Joshua. We're all professional, and they are in the sector. All right. So you guys should ask questions, go over it, and that will help us a lot. Because honestly, there are a lot of things I want to say here. Even maybe do labs to demonstrate so that you can really get the concept. So just like I've said, the public subnet. What makes this guy public is, we have this route, all right, that is pointing it to AWS router. That okay, this guy is no more staying locally. He's no more staying within the VPC. It wants to go out to the internet. If you buy an EC2, one of the things you want to do is you want to do DNF, YUM, updates, all those things you are doing. You have to go to the internet, right? You want to do YUM, install, HTTPD. Without internet, you cannot do all those things on your EC2, right? So you need this public subnet. All right. So this has to be in your route table. Then your EC2 has to have I think by default, just like we said, AWS will give you an elastic IP that comes with the EC2 you're provisioning. So, but what are the things that you want to keep in private? For example, your database, your RDS, you don't put them in a public subnet. Mostly like RDS, your database. Your database contain a lot of information, people information. You want to keep them private. So you keep those kind of things in a private. That's why, because I know some of you might have been wondering, why are we having different subnets? Why can't we just use this guy once and for all? Why do you have to split our network? Now that's why I illustrate an house. The reason why you have kitchen, room, database, most of the time you want to make it secure. You don't want it to access the internet. So you want to keep it private, so you keep it here. So it does not have this guy here, all right, in that subnet. I don't know if you get that. So something we call NAT gateway also. Something we call NAT gateway. Now, there are sometimes, even on your RDS, I'm just using that as an example. You want to download something, not necessarily for your RDS, even for your ACS also. There are sometimes you don't want to use, Mr. Victor dropped something in the chat. You can check it out. So you don't want to, sometimes you don't want to use public subnet, especially majorly for your sensitive resources. One of the key service or key technology that you can use is NAT gateway. NAT gateway, what it does is that it masks, it translates your IP address. It translates your IP address. All right. It translates it from private to public. All right. So, and sometimes it's you can use NAT. NAT can enable you to NAT can enable you to share IP address. All right. What NAT does is that it map private IP, to a particular public IP. You can have one public IP, and all your resources will be sharing that public IP. If you have NAT, NAT is just translation. It translates IP. All right. It translates IP, and that's why you see they are putting gateway in all these things, right? They are putting gateway. So, say for example, this one is public subnet, and you have your RDS here in this private subnet, and you don't want to, assign it to a public subnet. You can use NAT on your route table for your private subnet. You can have something like this. You can create a NAT. All right, you can create a NAT gateway. Now, this NAT gateway now will not expose your, you are using a private IP to access the internet now, right? You are using, maybe you want to download some patch, or you want to download some, some updates. All right, so you need to access the internet. You can use NAT. You can go through NAT. NAT, what NAT does is, we are using that private IP. So it's the NAT that will do the translation. So it changes your IP. You are not using your original IP. It's not your original IP that is going over the internet. So your location is not known. All right, it makes it secure. That's what NAT does. You can see that's why it's added to the private subnet here. So if peradventure you want to go to internet, just go through NAT, right? So I don't know if you get that. Our time is almost up. You see, and it's not even. You didn't get that. Someone did not get that.
I think anyone or someone said that they didn't understand that. So let me explain NAT gateway for you in a way that you should be able to understand. Okay, so say you're in school, right? You're on campus, maybe Gidankwa campus, right? And you connect to school Wi-Fi, so maybe Google Wi-Fi or the Wi-Fi at NIHOB, right? Now, when you connect to that network, the router at NIHOB will assign you a private IP address. Now, if you want to do anything on the internet, you cannot use that private IP address to do anything on the internet. That's like your words. You can almost call that your, not really a subnet, but that could go in your private subnet. Now, if you want to interact with the internet, you need a public IP address. Now, Toye mentioned something that when IP addresses were being created, because they were not managed properly, it led to a lot of wastage. So now there's a limited number of public IP addresses available. So what happens is that you would share a public IP address with multiple people. So now going back to our example of connecting to school Wi-Fi. So school has a public IP address, right? It's something like 154.200. something. I've forgotten the exact IP address now. And you can do this experiment, right? You can do this experiment anytime you're on campus in GK, right? Go to Google, right? And search what is my IP address. And there you see the public IP address. As long as you're connected to any school network, any Wi-Fi provided by school, right? Any Wi-Fi provided by school, whether it's at ITS, whether it's at NIHOB, whether it's anywhere, you should get the same public IP address every time. And anyone who wants to try it, please go ahead, do that, right? Connect to any school Wi-Fi, right? And then try it. Check what is my IP address. Just search it on Google, and you would see that your IP address should start with something like 154.200 or something, right? So now, anytime you're on school network, right, everybody is using that public IP address. Everybody is using that public IP address to access the internet. As long as you're connected to school network, that public IP address is what you're using to connect to the internet. Now, on whatever network you're on, you would also have a private IP address. That's what identifies you on that network, right? So when you connect to the network, the router will give you a private IP address, and that's what other network devices on that network will be able to identify you. So maybe if, like now, in the case of the NAT now, say you want to download something from YouTube, right? You have your private IP address. Obviously, that can't work, right? You use the public IP address of school. Now, on the internet, it is seen that, okay, Victor is trying to download something from YouTube. Yusuf is trying to download something from Google Drive. And I'd seen it as the same IP address. Now, when it has done the download, right, it needs to be able to figure out, okay, send YouTube to Victor, send Google Drive to Toye or to Yusuf. Now, it can do that using your private IP address, which is what you have on the network. So it goes out, uses the public IP address to fetch whatever it needs, gets it, returns it to the router, and then the router can now direct, okay, Victor is the one that requested for YouTube, send it to this private IP address. Yusuf is the one that requested for Google Drive, send it to this private address. So that is the major, that's a form of illustration. I don't know if that helps to understand NAT gateway, public IP addresses, and private IP addresses. Does that help a bit? All right, great.
Yes, sir. It's well illustrated.
Yeah, very good. Ah, our time is even up, and I see we still have a lot. All right, guys.
What we'll do, let's just, Engineer Terry, do you still have some time?
Yeah. I have some time. I don't know if they are willing to.
Okay.
Go on.
Let's see. If you want us to continue the class for a bit longer, please use thumbs up, or better still, type yes in the chat. Then if you don't, maybe you have something else to do, just type no. And based on that, we will decide whether we are continuing or not. So please, in the chat, just type yes if you want us to continue, and no if you don't want us to continue today. Okay, I see 3 people said yes, 1 person said no, 2 people said no, 3 yes, 2 no. No, okay, that's 3 yes, 3 no. We need a deal breaker. We need 1 more person to pull. So based on that, we'll judge. Okay, that's 4 no, 5 no, 3 yes. So today, I guess
There's a lab for this. There's a lab on this guy, right?
there's a lab. There's a lab.
On VPC.
There's a lab. Oh, now I'm
Yeah,
seeing 5
maybe
years, 5 years.
I think
Yes,
the lab
they should go to the lab. It's part of.
Yes.
Yes, it
Yeah,
will.
I'm saying,
And
yeah, it's exposed. Although the lab does not have nuts and does not have, does it have? I'm seeing a, because I'm seeing ACL also. Seeing. Okay.
launch a web server.
Okay.
We didn't even get to Route 53.
We didn't get to the. It's even still far away. No, not far actually. To ask. Yeah.
I don't know. Do you think maybe we should still touch on this module 5 in the next class, because this networking aspect is very important in the cloud?
Yeah.
Yes, sir.
It's very important.
I think what we'll do is next week we'll still do this networking. We'll just continue from where we stopped, because it's one of those very important topics. If you get it wrong from the get-go, it can really do a lot of damage.
You need to touch security group and ACL with the others that things they'll be dealing with.
All right, so that's it then. We'll continue from here next Saturday then. And I don't know, will you be available?
Yeah, sure. Next Saturday, right? Let's see.
We'll discuss that. We'll discuss that. All right. Thank you, everyone. Thank you, Engineer Toye. This was a great class. I learned a lot and I enjoyed it as well. Thank you, everyone, for joining. We will make the recording available, and we will continue from here next week as well. Right. And as we say here at AWS Academy, have awesome weekend. Goodbye.